Hello and welcome back to Calculus 2, section 6.4 on shell method. Instead of slicing the object perpendicular to the axis of rotation and getting disks, now we're going to slice parallel to the axis of rotation and obtain shells. So instead of slicing perpendicular to get disks, we slice parallel and we get shells that we can stack one onto another, and it will also create the object. Important thing is still for object to have a circle, right, to be obtained by rotation. Okay? So we are going to start with observing the example. Well, first off, let me write the formula, which says that so shell volume is equal to 2 pi now. All right? 2 pi integral a to b, p of x, h of x, dx for the y rotation. Remember that your disk method was dx and x rotation. Now it's dx and y rotation, which would immediately make sense because we are cutting parallel instead of perpendicular, but we'll get there. The other formula is 2 pi c to d, p of y, h of y, dy for rotation on x-axis. Now, hopefully you see 2 pi r in these formulas. Do we all see 2 pi r? R being the radius of rotation. If you see 2 pi r, then you know that that's your perimeter, right? And then we just need to stretch it, right? And you are getting your shape. So it operates differently. The way it works is, no blue. The way this works is, if I have some shape, say line like this, and I rotate that line around y-axis, you will get the line on the other side, and then there will be this circle on top, creating this upside down cone. Now, I have also this line here for the top, and I have my A and B limits here. If I draw a representative rectangle which travels from A to B, you see that the top function here is f, the bottom function over here is g, and this particular integral would be v 2 pi a to b x, I'll explain this, times f minus g dx because it's a y rotation. So y rotation shell method gets you dx. Now, what just happened here, and what is the p and what is the h in formulas, and what's going on? And could we just skip all of this because we just have the disk method, which was nice, clean, and understandable, right? Well, we are starting with p and h. Your book doesn't do it this way. Your book just says xf of x and good luck. The reason why I have p and h, p stands for position, h stands for height in these formulas. Now go ahead, use the book one, I don't care. P stands for position, H stands for height. Now, position P of x is in 99.9% of the problems just x. So P of x is almost always x, and P of y is almost always y. Cases when it's not, we're going to cover a little bit later. Age is going to be your function, and age is the height of the rectangle. Now you see that my rectangle is stuck between f and g. Now we subtracted f and g when we had area between two curves. We subtracted f squared minus g squared when we had two functions to rotate. You are still going to subtract them if you have two functions given to get the stuff in between. If you have a problem that it's nice and easy, something like, let's say, you want to rotate parabola, but you want to rotate the bottom piece of the parabola, like that, from A to B around y-axis, then you are getting this weird, whatever this is, right? It still has, it's hollow. It has the full base. It's like a glass for for that expensive drink, right? Put the ice inside, right? And then just like a finger of like $3,000 drink on it, right? That's what it looks like. However, these edges here are so sharp, like this is insanely sharp, these edges, right? You gotta grind it out a little bit there. So this shape has the representative rectangle right here, dx on the bottom, as opposed to the one that it's on top. And this formula is the same as above, except you just have one function. This is the formula given in the book. It only serves one case. The formula that I gave you takes care of a lot of cases. So this is our second example of the shell method. One thing that you need to notice now is that your representative rectangle dx and your axis of rotation y are parallel. In previous cases, your representative rectangle and your axis of rotation will always perpendicular. That's what I mean by a cut. You cut perpendicular for disk, you cut parallel to shell. And the cut happens where the dx is, or dy. So let's take a look at an example of, let's just do a very basic problem. Y equals 2x. Y equals 2x on, let's go 0 to 3. Rotated on the y-axis. I am going to draw the picture. Now, y equal 2x means it goes up like that. X equals 3 is where it stops, which means 6 on the y. And we are rotating on y, which means we are creating a cone, upside down cone, right? That's what we get. And what I want to calculate here is the volume of this cone. We also have y equals 6 as a stop, but we know that because when you plug 3 into 2x, you get y equals 6. I can specify it, I don't have to. So, shell method. Volume is 2 pi, and since I'm rotating on dy, I will be using dx for the shell because they don't match, right? They have to be parallel. And my dx is, as we discussed it earlier, here, because that's where the material is, right? That's where the mass of the object is. It's not below the function. It's air below the function. It's air all around it. So I will have x and then 6 minus 2x dx. From 0 to 3, I have to use x limits because it is an x integral. So this is the shell method, and I have my p of x is always x unless the axis of rotation is shifted from the origin. That's the extra piece for later. And the function that I'm computing has the top minus bottom because there is a function y equals 6 on top and the function y equals 2x on the bottom, so 6 minus 2x. And now I get to compute this. Well, first I'm going to simplify. 6x minus 2x squared dx, and then I integrate with 2 pi. 6x squared over 2 is 3x squared. And minus 2/3 x cubed from 0 to 3. That will be 2 pi open parenthesis 27 minus 1/3 would cancel 18. So 18 pi. Is that good enough? Rory, what do you think? Good enough, 18 pi? Sounds like it. Now let's do the same problem using the disk method and confirm 18 pi. If I have the same problem using disk, I will have to use dy because it's a y rotation. You don't get to change the rotation. You don't get to change functions, right? You can use different method sometimes. And since the rotation is set, you are going to come up with the same answer if the other method is possible. Well, in our case, luckily, method is possible. We have our function that goes like this, and we need dy from 0 to 6. Now, this function, which used to be y equals 2x, we have to flip into y over 2. Disk method does not have 2 pi, so we just put pi, integral 0 to 6, and we have our y squared over 2 squared dy. That's our disk method problem. Pi, integral 0 to 6 of, why did I put y squared? It's just y over 2. Pay attention. Y squared over 4 dy, and that's pi y cubed over 12 from 0 to 6. This is pi 6 times 6 times 6 divided by 12. That will cancel to get a 2. That will cancel to get a 3. 18 pi. Same. It must be the same because same function, same shape, same object, same limits, same rotation, same everything. Different method. So if you are not getting the same numbers, look for your mistakes. And most of the mistakes are obviously not realizing that this is between two functions. So you have to do top minus bottom or far minus close, whatever you want. So now we solved the same problem with two different methods, and we're bound to have at least one student ask, why? Why would you learn a completely new method, right, which seems to be opposite of the first one because dx and dy don't match the x of rotation? And the reason why is because certain problems cannot be done with the disk at all. Other problems cannot be done with a shell at all. And then some problems can be done with both. In some cases, one is easier than the other. So I would like to show a problem which you cannot solve using a different method. Yes?
So I just want to clarify. When you did the shell method before, even though it was rotating about the y-axis, you just like flip it then, and like if it was rotating around.
I did not flip it. If you look at the formulas up there, the x rotation asks for y integral, and that's opposite from the disk. In a disk method, y integral, y rotation. In the shell method, y rotation, x integral. It is very beneficial if you put all of these formulas next to each other and then see the differences. Do not forget to put x rotation and y rotation so you can see what's what. Let's take a look at, I know I'm going to regret this, but it's amazing example. Y equals x squared minus 6x plus 10. Everyone's happy. Y equals negative x squared plus 4x plus 2. Everyone is still very happy. And then I put y rotation and everyone goes, ah. Right? So when you draw this, and you don't have to be an artist to a little bit of math does the trick. The one that has negative x squared is the one that opens down and should be the one on top, right? And the one that has x squared is the one that opens up, so that better be the one on the bottom to create a shape, like the football, right, shape. So if I call this one f and this one g, then I have my f and g over here. I don't have my a and b, and I still need to crank the, set two functions equal to each other. We have our y rotation, though. That means we must use shell. Because functions are forcing a use of dx. Do you see that? You can't draw dy in this situation. If you have two functions intersecting like this, and you draw dy, do you see how dy touches the same function on both ends? That's not bueno. You can't compute that. When you subtract something from itself, you get 0. You're not going to get anything there, right? Which is how you know that you must use dx. But if you are using dx, then you must have x rotation for a disk, but you don't have it. You have a y rotation, which means that you have to use shell method. So dx plus y rotation equals shell method. This is the first time that I did this analysis. And this is the analysis that you have to do when you see a problem, or when you see the problem on exam or a final. They don't say very often which rotation to use. You as engineer, use whatever the hell you want, but it has to fit mathematically, right? So the way I deal with this is I say my functions are forcing me to use dx. The situation, which is application, is forcing me to rotate on y-axis. Dx plus y rotation is shell. You can see that in formulas. dx plus y rotation is shell method. What do we have for disk? For disk method, we have what? Very good. You can see that dx and x rotation, right? So these are the things that you are learning, right? You have to learn that. So dx and x rotation is disk, dx and y rotation is shell. No, switch. There we go. So the problem forced me to use y rotation. The functions are forcing me to use. You can't flip these functions into x equals, right? That's why I say the functions are forcing me to use x. I can't write those functions as x equals blah, 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 y. So the problem is forcing me, the functions are forcing me to use dx, and the problem is forcing me to use dy, so we use the shell method. Let's go. Volume is 2 pi integral. I don't have the limits. Set these two equal to each other, get the limits. Nothing new. X squared minus 6x plus 10 equals to negative x squared plus 4x plus 2. So that's 2x squared minus 10x plus 8 equals to 0. Factor out 2 and then kill it. X squared minus 5x plus 4 equals to 0. You divide both sides by 2. That kills a 2. And then we have x minus 5, x plus, no, lies, x minus 1. So x are 1 and 5. So those are my 1 and 5 limits. That's what I said. Please pay attention. It's clearly 1 and 4. I'm not sure what you're talking about, but it's clearly 1 and 4. So now we have the limits 1 to 4, and we have our position P of x. I'm just going to put P of x right there. And then we have to go top minus bottom, upper function minus the lower function for the height of the piece which you are rotating. So that's negative x squared plus 4x plus 2 minus x squared minus 6x plus 10. Then you close these 15,000 parentheses and you have dx at the end. All of this is your age of x. Two pi integral 1 to 4 x times, we have negative 2x squared plus 10x minus 8 dx. You distribute x, negative 2x cubed plus 10x squared minus 8x dx. And finally, you integrate 2 pi negative 2x to the 4 over 4, will simplify, plus 10x cubed over 3 minus 8x squared over 2 from 1 to 4. So volume is 2 pi. Simplify all of this. This is going to be negative 1/2 x to the 4th plus 10/3 x cubed minus 4x squared from 1 to 4. 2 pi. Plug in 4. 128. Okay. So negative 128 plus 640 over 3, okay. Minus 64, sure. And then we have minus, and then minus makes a plus, so plus 1/2. And then minus 10/3, and then plus 4. As you wish. 2 pi. That's what? Negative 192. 196.5 plus 1/2. And then 630 over 3 is 210, right? So let's say this is all good. Two pi. Multiply this by 2 so you can get rid of the decimal. Right? Oh, it's negative. Oh, then we can just subtract because you have 13.5. That's better. Times 2, 27 pi. Let's say it's good. If you are struggling with computing integrals with limits, I hope that you will open your favorite integration app on the computer, stuff the problem in there in its basic form, including the 2 pi, and then just hit the button, hoping to get that 27 pi at the end. Yes?
You're 196.5. You have to minus 8 from that because you had, instead of, you did negative 128 minus, or
64.
minus 64, then you also minus 4 of that instead of plus 4.
Why minus? Oh, because I went the wrong way. That was minus 96. Okay, so what am I supposed to do? There was 192, negative 192, right? So that will be negative 188. Right? Negative 188. And then negative 187.5. Is that good? So now that's not 13 anymore. What do we have now? So we have negative 192, and then I have to add 4 to get negative 188, and then I need to another half, so negative 187.5. Okay, cool. All right. So what am I missing? I'm missing 12. So now it's 22.5. So it becomes 45 pi. Good. I was just testing you all, and obviously Max turned out to be the only one paying attention.
Can you just explain P of x again? I understand like where the h of x comes from, but like.
P of x is measuring the distance of the representative rectangle from the axis of rotation, and that's always x units or y units. Unless the axis of rotation is shifted. Unfortunately, I don't have the time now for shifted axis of rotation, will be the first thing next class. But if you shift the axis of rotation from y-axis to, let's say, x equals -1, then the distance that the dx has to travel has an extra unit that it has to cover, and then your px is no longer x. It becomes x plus 1 because it has an extra unit to travel. So all of the problems that are given in the book are always considered from the axis of rotation, which is why they don't use P of x, they just use x. Right? But if you want to add extra degree of freedom and move the axis of rotation away from the axis, like x and y, then you use P of x. And as I said, anytime that it's at the axis of rotation, you just call it x or y. But if it gets shifted, right, then you have to add 1 minus x or 1 plus x or so on, depending on how much you squished your or extended your travel for the x. Yeah, what? Cool. Yes.
For disk method, do you square the function before integrating, or vice versa?
Always square before integrating. Yes. That's why we had to use the power reducing formulas for trig, because we had to deal with the trig before we integrated.
Yeah. And I think you answered this before, but after squaring, you're allowed to combine the formulas of the two different
If you can, yes. If you can, you put those together. Guys, I'm just going to write this in blood at the end over here. We have negative 19 seconds left for the class, which means we're over time, right? So, x rotation plus dx is disk slash washer. X rotation plus dy is shell. Y rotation plus dy is disk, very good, and the washer. Y rotation plus dx is shell. So this is going to help you solve the problems when they say in a homework or the exam, just what's the volume? And they give you rotation. They give you functions. They don't say use blah blah method. As I said, the previous problem, right? This example can be done. You've seen it with shell and the disk, and we got 18 pi with both. This example, which I did here, cannot be done by disk method at all, because you cannot flip the functions to be in terms of y to satisfy the condition y rotation plus dy to give you the disk method, right? So you were forced to use dx, and you forced to use the y rotation, which means that we are forced to use the shell. We'll do a couple of more of these examples, obviously, on Thursday to make sure that disk and shell are good, and then we'll move on to 6.5.